Yo, what's up? So this is just a quick walkthrough of all of the Lab 1 code that we wrote, starting with the serial IO file. Here, obviously, we're using the ring buffer data structure that we defined in our homework. First, we have what are probably the two most important functions, USB read and write data, where we're essentially kind of copying the echo code from later, but we're just checking if the USB is configured, setting the right endpoint, making sure we can send data, and then in the case of read, we use the endpoint read function to kind of take that byte and just push that onto the receive buffer structure that we defined. Then, if we can no longer read and write, we go ahead and clear that out. There's something very similar going on in write data. This time, though, we're just using the endpoint write function to write the latest part of the buffer. Then moving on, I think this was already defined for us. Echo was obviously already defined. Then we go into just sending all the data, which just looks like to send a single byte, we're going to just push onto that ring buffer structure to send data, kind of go through any struct. I think the void pointer means it can be any type of structure like object being passed in here. We are just going to iterate through that and run send byte on each part of it to send the full data over. String is just going to iterate through the whole string, and you send byte to push that over. Then we have send message, which is just kind of the general function we're calling anytime we want to send a message over, where we have the format, the actual commands, typically like the char that's being passed in, and then the data. We need to calculate the format length because one of the message formats needs the total message length. We don't have the format length, so we iterate through the format. We calculate the total message length, and we send all of that over using previously established data, like the byte and the string and all the functions we established. Message length just gets the length of the buffer right then and there. Message peek allows us to look at what's coming up on the buffer without actually popping, so that's useful if we don't ever want to cancel out what the value is, but we want to kind of have an idea of it. And then getting the message just looks like popping from the front of the buffer, and this the read into just kind of takes data from the buffer and kind of adds it to some object that we passed in. So you have like a struct that you want to hold all the data from bytes that you're from some data that the buffer has. You want to pass it on to the struct. This will just iterate through the buffer to kind of push it all on there. Flush input buffer just reinitializes the buffer. If we ever don't want to just throw away or clear the data on there. I think that was it for the serial IO file. Then task management was relatively simple. We're just defining the task struct. So I think this was already defined for us, all like the different pointers and stuff, all the data that we need to keep track of for the task. But just some basic. If you activate the task, it should be activated. If you reactivate it, it should be activated. If you cancel it, it should be canceled. If you want to check if it's activated, it just returns that. And just easy stuff like that. Then over here in message handling, I think we had an example of how to do the asterisk command, but we basically we start by checking if the message, the current message length inside of the buffer, like receive buffer, matches up the message length that corresponds to the char that we received. So I think that's defined at the bottom, which is like the dictionary. We actually get that char, so this is getting like that / command. We define this little struct just so then we can pass it on to a function that I'll talk about in a little bit, so we can pass on like the two float values on there. We use that read into to kind of load that data into the struct and then pass it on to the divide function in this case, or add or subtract later on. Also, some special cases if we have. I think it's called a tilde, whatever this is called. Whenever we run that, we need to process that at char, obviously, but we also want to just kind of reset the system, which just looks like resetting our restart flag. Then here we have the default, which just gets that whatever. If a letter was sent that wasn't defined by the system, we just want to kind of flush that out. We don't want to keep any of that data, and we want to send a message just being like, hey, dude, what's up with that? Then in lab 1 task, super simple. We just went ahead and I think multiply might have been defined for us. I don't know why it's commented out right now, but it's fine. But here you have like divide. That's just taking, we pass in this data from over here. I don't know if you remember, we loaded the message data into the struct and pass it into divide. So then we're able to just like do some basic math, store that value, and then return that, actually send that through a message to get that over to the serial monitor. And I believe that was everything that we had to do for lab 1. I did it a while ago, so I don't remember. But now I'm going to cut to just some footage of the serial monitor working and kind of showing off the code. Connect. It is connected. Ooh. Watch me do some quick math. Oh, fuck, I fucked that up. Well, this is fine. It doesn't matter. Ooh, that's 2 times 3. Oh, but what if you divide it? It did the float math. Plus, this is all being edited out. It's fine. 5. Oh, isn't that cool? Oh, now watch this. It doesn't do anything because it's like resetting it, I think. I hope that's what it's supposed to do. I'm not sure about that. And then what if you type in a strange letter? Ooh, question mark. Ooh. I don't even